This is Chapter 8, Univariate Data Analysis, Section B, Quantitative, or as we say, numerical data. So if we recall from our terminology from Section A, let's just remember what quantitative variables mean. So there's two types, right? We talked about discrete and continuous. So discrete variables take exact number values, and it's often the result of counting. A quantitative continuous variable takes numerical values within certain ranges, and it's usually the result of measuring. So there are numerous ways to organize and display discrete data. So here we have 3 examples. The first is a tally frequency graph. Sorry, I'll just highlight that there. Okay. So on my right here in green is where I have my data points, or my data values. So I have a lot of different numbers here, and I need to find a way to organize them. So one way is this data tally frequency graph. So it starts off with looking at number of pumpkins per plant. So here's all the numbers here. So if I look at this first one, 4, it says, well, there would be 4 pumpkins per plant. And then I would have 7 pumpkins per plant, etc. But I need to put this in an order. So usually you go in a numerical order from least to greatest. So if I go through my data and I'm trying to find, okay, how many times, what's my lowest number? So I'm scanning through, I see a 3, that looks like my lowest. I'm gonna highlight it. There's 3. I don't see any 2s or 1s, but I see another 3. So if I go over to my graph, I'm going to write 3, and then my tally would be 2 because it happens twice, right? There are 2 plants that have 3 pumpkins each, and so my frequency would be 2 because it happens twice in the data set. If I move on to 4, well, I already have 4 highlighted once. Let's see if I can find it again. I'm scanning through my data. There's 4 again. Keep scanning for a 3rd time and for a 4th time. So then I go over to my tally frequency graph and I would write, well, there's 4 pumpkins per plant. That happens 4 times. So I'm going to use 4 tick marks to represent that in my tally, and the frequency of that is 4. So there are 4 data values, or 4 plants that have 4 pumpkins each. So that's one way of graphing my data. It's called a tally frequency graph. And this is on page 176. Oh, I always do that with my highlighter. Let's erase that. This would be page 176, 177, if you want some further information or you want to look at the textbook. The other 2 types of ways of graphing our discrete data would be a column graph or a dot plot. So the information is the same here. We're looking at pumpkins per plant, which is our independent variable. Remember, our independent is on our x-axis always. So there's our independent. And our dependent would be our frequency, so how often it's happening. So again, 3, there were 3 pumpkins per plant, and that happened twice. So if we look at my graph here, well, it hits up at the 2 mark. And then for my 4 pumpkins per plant, well, that happened 4 times. As we look at this graph, we can deduce some information, which is what we're going to start to learn how to do. But just right away, we look at, well, the most pumpkins per plant was 7. Sorry, the most frequent number of pumpkins per plant was 7. But the most number of pumpkins per plant was actually 9. So we can find different information from this. Let's talk about describing the distribution of data on a graph. So first of all, we need to understand what the mode is. So the mode of a data set is the most frequently occurring value. And so most data will show a symmetry or partial symmetry about the mode. So if you look at this first graph right here in green, we would say that this is a symmetrical distribution because of the way that the mode is in the middle and it's our highest peak. Now, sometimes we can have either negatively skewed data or positively skewed data, meaning that there is a stretch on one side or the other of the mode. So a negatively side a negatively skewed data or distribution would be a stretch on the left side of our mode. So if this was our mode here where this dotted line is, we have this big long stretch on the left side of it. And so that would be a negative distribution. Whereas a positive distribution is the opposite. We see this mode and then there's a large stretch towards the right-hand side of our data. So we have symmetrical, negative, or positive. Now, the other thing that we need to talk about are outliers. And you've probably heard of this before, but let's just go over it in case. So outliers are data values that are either much larger or much smaller than the general body of the data. So outliers appear separated from the body of data, and you can really see it on a frequency graph or a line graph, a scatter plot. Those are all really good ways of seeing it. So let's just think about these numbers. So if we have the numbers 3, 1, 7, 6, 8, 18, 2, 6, 7, and 7. If you were to scan through those right away, you want to look for a number that really stands out, that doesn't seem like it should really fit with the data. And what number you should come across is this 18. All of the other numbers are less than 10, and in fact fairly close together. We see 7, 6, 6, 6, 7, 7. There's lots of numbers in that small range, but then we have an 18. So we would say that that is our outlier.